Hello and welcome to another math video. Today we're looking at our counting and probability quiz for FST 11.1 and 11.2. We begin with yogurt shop question. So in this case, the shop has 5 different flavors of frozen yogurt, 12 different toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? And what I do here is I think of this as being really 2 separate events. We have 5 choices for flavors, 12 choices for toppings, so we multiply those together, and the result, of course, turns out to be 60. So that's really what we get. Again, and we are limiting ourselves to just a single serving and 1 topping, but maybe we're on a diet or something, so but that does also limit our choices just down to a reasonable 60 different choices. Looking at number 2, we've got Ruth Ann. She has 5 routes she can choose from to get from school to the library, and then 6 routes from the library to her home. How many routes are there from Ruth Ann's school to her home with a stop at the library? So again, same kind of thing here. We have 2 different things. We have how many routes from school to the library, and that's 5. And then we have 6 routes from the library to home, so 5 times 6 turns out to be 30 for that one. Number 3, how many ways can you order or line up 6 cards on a table? And it's important here to understand we just have the 6 cards. It's not a 52 card deck. There are a couple ways we could do this one. You could do a 6 factorial, or you could do a 6p6. Oops, that's a 6. They turn out to be the same thing. They are both 720. So 6 cards in a total 720 ways that you could line those up. All right, number 4, we got Vern. He's got 8 math books to line up on a shelf. Jenny has 5 English books to line up on a shelf. And how many more orders can Vern line up his books than Jenny? So it's similar to the previous one, but now we have the added issue of finding the difference between the 2. Again, with the math books, that would be 8 factorial. In the English books, it would be 5 factorial. And an 8 factorial, of course, is going to be bigger. And we just subtract the 5 factorial from the 8 factorial, and we should be coming up with an answer there of 40,200. So again, quite a few more for that. And again, you can type that in and see what the different numbers are, but the difference should be 40,200. Now, number 5 can be a little tricky just because of the way it turns out. You got 11 basketball players in a program, so the answer would be 11 factorial. That would be the same as 11p11. In this case, the number's reasonable, 39,916,800. Depending on how the value for this particular question, your calculator may give you that answer in scientific notation. We would really prefer actually seeing the number, but if you are going to do that in scientific notation, the thing is you have to include all of those extra decimal numbers. So at that point, it ends up almost being easier just doing the number in normal notation. Let's see, number 6. We got 7 students in the spelling bee. How many ways can the students who go first and second in the bee be chosen? So going first and second, that does make a difference. So this would be a permutation, so it's 7p2. And for 7p2, we end up with 42 ways. You could also use the fundamental counting principle. It's just 7 times 6. Number 7, how many ways can 6 singers be selected from 10 who came to an audition? Again, we're just selecting the 6 singers. We're not saying that, of the 6, you're first and you're second, you're third. So it's a combination, 10C6, and that ends up being 210 ways. Okay, now this one gets to be a little bit tricky. So we've got 7 people on the ballot for regional judges. You can vote for any 4. Okay, but you can also just vote for 0, 1, 2, 3, or 4. So the thing is you have to break this down into the different pieces because you can't really think of all of those things at once, the ways you can vote for 0 or 1 or 2 or 3 or 4. You really have to deal with that individually. Now, 7C0 is just going to be 1, but just so that it fits the pattern of how we're going to write that all out. So 7C0 is 1, then we would have 7C1, which is 7. And so those two we can kind of figure out without having to think about it much. But then we get into a 7C2, which is a little tougher, like what is that really? 7C3, and then 7C4. You can't vote for 5 or 6 or 7 of them, but you can vote for 0, 1, 2, 3, or 4. So remember, 0 to 4 is 5, so that's why we have 5 different things that we can vote for. And of course, you put that in the calculator and get the total. Just be very careful how you type that in. Again, this is one of those questions where it's hard to have a great feeling for how many different ways this could be done. So it's worth your time to double check, make sure, maybe even type it in once, double check that, and then just go through and type it in again, start over from scratch. Make sure you get the same answer twice. Again, because you do one thing wrong on the calculator and the number's wrong, and it's hard to really have a good feel that, hey, there's 99 ways that this could happen. So be careful with that one, but that is how you would set that up. Once you know that trick, there's not much to it. Okay, next we got Lynn Dawn tossed a coin 50 times, got heads 24 times. What is the experimental probability? So their experimental probability, again, it's really just the 24 over 50. Of course, I would want to reduce that. That turns out to be 12 out of 25. I'm not really too worried about getting a decimal or percentage there. 12 out of 25 is just fine. So I would really just leave it like that. Not sure. I guess it's not a bad decimal, so I would take 0.48. I'd also take 48%. And again, this is not rounding or anything. This is exactly 48%, which is the 12 out of 25. So any of those three is fine. But again, I do want you to be careful with changing to decimals or percentages if they're not nice numbers. All right, moving on to page number 2. So you got the classic bag with marbles in it for number 10. So we've got 5 red marbles, 6 white marbles, and 5 blue marbles. Find the probability of red or blue. Well, we're talking, let's see, red or blue would be a total of 10 marbles, and there's 16 total marbles. So 10 out of 16, but again, we don't really want to leave that as 10 out of 16 because that's not reduced. So 5 out of 8. And eighths aren't too bad. That would be 0.625, and again, that's exactly 0.625. So I would accept that decimal, but don't round that to 63 or 62.5%. So any of those three would be fine. 5 over 8, 0.625, or 62.5%. All right, so number 11, we've got a spinner numbered from 1 to 10. Each number is equally likely to occur. What is the probability of obtaining a number less than 4 or greater than 7? So just be careful here. Less than 4 would be 1, 2, or 3, but not include 4. Greater than 7 would be 8, 9, and 10. So just make sure you're being careful there. If it's less than or equal to 4 or greater than or equal to 7, then that would be different. But so we really have 6 favorable outcomes out of 10. Which is a fraction would be 3/5, obviously 0.6 or 60%. So 3/5, 0.6 or 60% is what we're looking at there. Okay, so number 12, a little bit of a goofy one here. We got Tisha in the French club. There's 32 students in that club. French teacher will pick 2 students at random to guide visiting students from France. What is the probability that Tisha will not be picked as a guide? So a couple different ways to look at this one. The way that I like to look at it is when they pick the first student, there's, forgot to change back to my pen there, sorry about that. When the first student is picked, there are 31 out of 32 that are not Tisha. And then when they go to pick the second student, then there's 30 out of 31 that is not Tisha. And of course, we're assuming that Tisha is not picked in order to find that probability. Now what happens is the 31s cancel, so we get 30 out of 32, and of course that reduces down to be 15 out of 16. Now 15 out of 16, that's not bad really for a decimal. 0.9375, again, that's exact, don't round that, and then that would be 93.75%. So again, any of those three, 15 out of 16, 0.9375 or 93.75%, Again, really, if you get to the 15 out of 16, you can just stop there. Okay, so number 13 is our combinatorics question. It's always going to be some kind of combination like this. Exactly 3 10s in a 5-card hand from a standard 52-card deck. So there's 4 10s in the deck. We want to figure out how many ways we can get 3 of those. If we have 3 of those, then we need 2 non-10 cards, which there's 48 cards that are not 10, and we need 2. And we divide that by how many total hands are possible, which should just be 52C5. And just so you can see these numbers here, the 4C3 is 4, and then the 48C2 is 1,128, and then the 52C5, that's that big number. Let me check that one quick here. 2,598,960. So that's what it looks like before putting that in, just so we can see. And that ends up being 4,512 over the 2,598,960. Now, a lot of calculators are not going to be able to reduce that down because the denominator is too big. So I am, I guess, fine with the decimal and percentage approximations. I can also show you, I guess it'd be 4 if I round it, how to reduce that on your own, which basically kind of just gets down to reducing it by hand. Let's see, where was I going with? Oh yeah, so that's as a percentage, 0.174%. Now, reducing that by hand, again, just a little mini lesson on that. Like the 4,512, I can tell at least that that reduces by a factor of 2, and so does the 2 million number. So if I do that, again, if you want to put in a little extra work here to get the bonus brownie points for reducing this, then I can reduce them both by a factor of 2, assuming I don't mess this up anywhere along the way. Then I can see, well, they still have that common factor of 2 because they're both even. And so again, you can kind of just continue with that until you get it down. And then, at some point, if the denominator gets a little bit smaller, then you may be able to reduce that down, but I'm not sure even really if that would still work. So I'm not going to continue with that because I'm sure you don't really want to watch it. But you could reduce that by hand just because the calculator can't handle the denominator so that big, which is just a good example where you need to be smarter than the calculator. So number 14, probably the dart will land in the shaded region if a dart hits the target at random. So we are dealing with area of circles, so we've got the inner circle radius is 4, so it'd be pi times 4 squared, and then pi times 16 squared. And again, we did look at one of these where it appeared where the 16 would have just been the outer area, but this one, again, looks like the whole thing. Again, the pi's cancel out. We get 4 squared over 16 squared. So 16 over 256, that does turn out to be 1/16. So that's our probability. Guess we could look at the decimal there, 0.0625. Again, that's exact, don't round that. That would be the same as 6.25%. So any of those 3 ways is fine. And that is all that we've got for you today. So hopefully you found this helpful, and thank you very much for watching.